Okay, in this video we're going to bring in dilations as well as translations into a quadratic transformation. So we're looking at transforming the graph of y is equal to x squared, our standard quadratic. And we're going to have a look at the turning point form. Sort of in general terms here, we've got y is equal to a, x take p all squared plus q. So it's the a value here which determines the dilation. Remembering the dilation is the stretch of the graph, and in this case it's the stretch in the y direction. We've got our p value, which is the movement left or right. And we've got our q value here, which is up or down. Remembering that the p value inside the bracket, it moves in the opposite direction to what you expect. Okay, so let's have a look at this equation here, y is equal to 2, x plus 3 all squared take 4. So first of all, let's have a look at the translations first, the movements left or right. We've got a value of positive 3 here, which actually means it moves in the negative direction. It moves left 3 units. The negative 4, so the value outside the bracket, that's the movement up or down. And the sign is, or the movement is in the direction that you expect, so this one will move down 4 units because it is a negative value. So it's down 4 units. And then we've got our dilation, so that's the number out the front of the bracket here. And so that's a dilation of scale factor 2. So scale factor 2, and it's in the y direction. So what it means is the graph gets stretched out in the y direction. So how do we actually sketch this graph then? Let's have a look at that. So we've got our movement left 3 units. So our turning point of y is equal to x squared gets transformed 3 units to the left. Then turning point also gets translated down 4 units down to here. In terms of the dilation, we're stretching it in this direction, which means that it actually gets narrower. Now to locate or to figure out how narrow, instead of going across one and up one as we normally would for our general shaped parabola, we go across one up 2 because of this scale factor of 2. Across one up 2. Also, we generally go across 2 up 4. In this case, we go across 2 up 8. 4 times 2 is 8. All the way up to there. Across 2 up 8. It gives us a good idea of how to sketch our graph. There we go. So you can see the graph has shifted to the left by 3 units. It moved down 4 units. And it's also become narrower because of the dilation in the y direction of scale factor 2. Let's just label that graph, y is equal to 2, x plus 3 all squared